Modeling using quadratic functions. We'll be looking at a word problem that involves revenue, cost, and profit. The monthly revenue R achieved by selling X wristwatches is figured to be R of X equals 75X minus 0.2X squared. The monthly cost C of selling X wristwatches is C of X equals 32X plus 1750. Problem A, how many wristwatches must the firm sell to maximize revenue? What is the maximum revenue? So here's our revenue function, which we know is a quadratic function because it has x to the second power. In fact, it's a quadratic function that opens down because if I were to write it in standard form, I see that my leading coefficient is negative. Because this function opens down, there will be a high point. We want to know what is the x value at that high point or that vertex. The formula for the x-coordinate of a vertex is negative b over 2a. So we can substitute into this formula the opposite of 75 over 2 times negative 0.2, and we can simplify, and we get that the business must sell 187.5 wristwatches to maximize revenue. Now remember, revenue is the money that comes into the business. We are supposed to figure out what is the maximum revenue, so we will substitute 187.5 in place of x in the given function. And we'll simply use our calculator and we'll determine the maximum revenue to be $7,031.25. Now turns out revenue is not the same thing as profit, because with a business there's always something called cost involved. And so we find out in part B, profit is given as P of x equals the R of x function minus C of x, which is the cost. And it's asking us what is the profit function. So we are simply going to write R of x minus C of x here. And we're going to use simplifying algebraic expressions. We'll distribute that negative sign. We'll combine like terms. And our profit function is also quadratic, negative 0.2x squared plus 43x minus 1,750. So now that I know my profit function is also quadratic, which opens down, there will be a high point for my profit. Part C says how many wristwatches must the firm sell to maximize profit? What is the maximum profit? Well, again, we'll use our formula for the x-coordinate of a vertex, the opposite of b over 2 times a, and we'll simplify that expression. And we know that 107.5 wristwatches must be sold to maximize profit. What is the maximum profit? We substitute 107.5 into the p of x equation, and we get a much lower number than the maximum revenue. We get $561.25 as the maximum profit. So you recall that the maximum revenue was very much larger than this. So my next thought is, okay, well, let's make sense of this using the graph. Let's grab a graphing calculator or Desmos.com, and let's graph the revenue function. And when we do, notice I have an appropriate x-axis, a scale, and an interval that's going to fit my parabola on there. And I have a y-axis that goes up to over 7,000. When I graph my function, I can see that there is a high point, which is sold, which is the maximum revenue, representing $7,031.25 if the business makes 187.5 wristwatches. But remember, that's not the money that comes in, because there's this cost function which is linear. Now remember, the linear function is positive, it's increasing, and that makes sense. The more watches you make, the higher the cost to make those watches. If I subtracted my quadratic minus my cost, that's my profit function, which remember is this equation, there is a high point for my profit, and the high point is located in an x-coordinate of 107.5. At that point, they make a profit of $561.25. So at this point, I think you would be poised to answer part D. If you look carefully at this graph, part D says, provide a reasonable estimate as to why the answers found in parts A and C differ. Why is a quadratic function a reasonable model for revenue?